Okay, so I think we've already talked about this briefly, like last week or something like that. But I'm just going to review it because there's a lot of problems on the homework relating to this, okay? So basically, this is multiplying binomials. Binomials would be like x plus 2 times x minus 3. Each of those are binomials. Binomials have two terms. They're separated by a plus or a minus, right? Okay? And so, if you had something like this, x plus 2 times x minus 3.
Oh my gosh.
Okay? It's going to be FOIL, my first of this binomial times the first of this binomial. This is first, this is first. Outside, O for outside. Do I need to write all this down? First. F equals first. O is outside. Whoops. Outside. I is inside. And L is last. Right? So first and first. Outside, this is think of this as like a house. The two outside windows are x and -3. So this is outside, this is outside. Like a house, the insides are the two right near the inner wall. So that's going to be inside, inside, and your last of each binomial. This is your last number of that binomial. This is your last number of that binomial. Right? So your first is x times x, which is equal to x squared. Your outside is -3 times x, -3x. Your inside is positive 2x, so I put plus 2x. And my last is -6. Everybody sees that, right? You all get that. These two terms in the middle can be combined. And so it's not correct until you simplify those two middle terms. So your final answer is going to be x squared minus x minus 6. So that would be your answer. If you left it like this, it would be not simplified enough, so you would get some credit marked off on a quiz or test. Okay? So, all right, let's try a couple. X minus 7 times x minus 8. All right. First would be what?
X times x.
Which is?
2x squared. X squared.
Yeah. X times x is just x squared, right?
Yeah, no.
And then we've got outside. What's the next thing you do?
X times -8.
X times -8. So what would that be? -8x, right? All right. Inside. What did you do?
-7 times x.
-7 times x, so -7x. Last, what would you do?
7 times 8.
Right.
-7 times 8, but it's the same thing.
Right, so which is 56, right? And it's positive, because negative times negative is positive. I can combine my middle terms, so my final answer is x squared minus 15x plus 56. Right? Pretty straightforward, right?
Yeah.
All right, now, watch this. What if I had something like this? X plus 9 times x minus 9. Notice the binomials are exactly the same. There's one little exception. There's a plus sign here and a minus sign there, but you have x and x, you have 9 and 9. You just have a plus sign and a minus sign. Let's see what happens. If we have that, we have x times x is x squared. Yes, there is a rule about this. You'll see it. You'll remember it very soon.
Oh, I remember.
All right, so my outside is what? What's my outside? Come on, everybody.
I know what -9x.
-9x. What's my inside? Everybody. 9x. Positive. Positive 9x. What's my last?
-81.
-81. All right, now I'm going to combine my two middle terms.
And make 0.
And they cancel each other out. Do you see that? Look, negative 9x plus 9x completely canceled out.
Yes,
right?
you can just do
Therefore, my answer is
9
this,
squared.
x squared minus 81.
So then
And what is that called? It's a binomial, but is this a perfect square right here, x squared?
Yeah.
Is 81 a perfect square?
Yes.
You can
And,
divide them
and
both
a
by
negative sign means what? Sum, product, quotient, or difference? Difference. So you're telling me that these are two perfect squares, and that's the difference. The difference.
81 is not a perfect square.
Well, 81 is.
Oh, okay.
But this is the difference of two squares. Remember that? Difference of two squares.
So
So
wait, then can you go further? with
now I'm going to go backwards. We're gonna.
it? Can you square them both sides or no? Or no? 'cause
Or
they're
no.
both sides.
No,
You
no.
have to find square
Okay,
root of
so
both, but they're not.
Can I erase everything? Because I want to. I'll keep this, and I'm going to show you something.
So basically though, if they're the same, if it's the same thing except for the signs,
If it's
you
the,
can just do F and L.
exactly,
Okay.
exactly. As long as the signs are different, but the binomials other than the signs are the same. All you have to do is first and last, because you just think of it as negative 9x plus 9x. They cancel out, right? It works for everything. X plus 3 times x minus 3, right? Well, x squared
Plus 9.
minus 3x plus 3x is 0. So I'll just say minus 9. Okay? So this is a perfect square. 9 is a perfect square. The minus means it's the difference of two squares, or difference of two perfect squares, right? All right, so now I'm going to erase everything, and we're going to go backwards. And we are going to actually have another title to this lecture now. And the title is this: Factoring Difference of Two Squares. These are really, really important to know because they're so easy. And if you get them on a test, it's like a present because they're so easy. Evan, can you just stick your head in there and ask if I could have 3 more minutes? Really fast before they ding the bell.
Yeah, you
So-
still got like 10 minutes.
Oh, I do?
Yeah.
When did this end?
Not until 9.
Oh, 9:10. Oh, never mind. Tell them I'm fine. I didn't know it ended at 9:10. I was thinking it ended. That's fine. Okay, great. We got more time. Yes. Okay. All right. Factoring difference of two squares. So, difference of two squares. Think about what two squares are. If this is an x,
Whoa, that's a box.
and that's a square, minus,
Oh yeah, I remember this part.
right?
That's a big box.
9 and 9, right? So this is going to be x squared. This is 81, right? Therefore, if I wanted to know the difference between this square, x squared minus 81, I could at least factor this. I could factor this. I could say, okay, the first is going to have to be what? X, right? That's the only way I'm going to get x squared. My first of both binomials will have to be x squared.
And then plus and minus.
Since there's no middle term, immediately I know that these two numbers have to be the same number. I know that because then I'll have them cancel out to 0. Because there's 0 x's in this, right? You see that? Do you all understand that?
Yes.
Because there's no middle term, I immediately know these two numbers have to be the same, but one has to be
Different
one
signs.
sign and the other has to be the other
Because
sign.
otherwise it would be positive.
Right, exactly. So,
It's minus 9 or plus
what is the square root of 81?
9.
9. Perfect. We put a 9 there and a 9 there. We have a plus and a minus. Let's just double check. X squared, yes. Negative 9x plus 9x is 0 x's, right? And then minus 81. There we go. So let's try another one. X squared minus 25. All right. There is no middle term. There's no there's 0 x's, right? So I know this is x, I know this is x. No middle term, these two numbers have to be identical. 5 and 5. Square root of 25 is 5 and 5. Notice if it's perfect squares, it always has a square root, right? Always has a square root. So the square root of x is x, the square root of 25 is 5. One's plus, one of them's minus.
Square, Clayton.
Really?
Right? Okay. Everybody fist to 5. Are you getting this so far? You remember this? Okay, these are good. Awesome. Now we're going to make it a little bit harder, okay?
Oh my gosh.
What if I gave you all right, so the first thing you try, absolutely, this is really important, okay? Before you actually factor it, you know, using the method I've taught, this is the first thing you try. First thing to try.
Wait, wouldn't it?
Right? And it is to factor
2x
out the greatest common factor. Okay, that's what you always try before you go anywhere else. Ah, there's a 4 here and 25 here. Can I factor something out?
Nope.
What? No. You're right, I can't. I can't, right? Nothing goes into 4 other than 1 that also goes into 25, and 1 doesn't change anything, right? So, Clayton.
So is it 2x plus 5 times plus 5 times 2x minus 5?
Yes, exactly. As long as you cannot factor out the greatest common factor, then you do your parentheses and you say, well, what's the square root of 4x squared? In other words, what's the square root of 4? Square root of 4. 2, right? So I'm going to have a 2. What's the square root of x squared?
X.
X. That means that if I have 2x and 2x, that would give me 4x squared. And that is right. And then, what's the square root of 25?
5.
5.
So you basically
5. One of them is positive, one of them is negative. And then I always check my work really fast. 2x times 2x is 4x squared. Minus 10x plus 10x, the middle cancels out.
goodbye.
Minus 25. There you go.
Yay.
Okay, now what about this one, though?
Oh my gosh.
What if it's 5x?
What about, hang on. Let me think about this.
X squared plus 1.
46.
Yes, David.
All right, what about this? 4x squared minus 36.
Why is it all
All right. First thing you have to try first is what?
Factor
Come on.
out the greatest common factor?
Factor out the greatest common factor. Is there something you can factor out?
Yes.
Yeah.
What is it?
4.
4. So we're going to factor out a 4 first. 4. And when I factor it out, the 4 stays, but it's got to be with a parenthesis. It's on the outside of the parenthesis. Now I have x squared what?
Minus plus 4 times what?
9.
9.
Yes.
Right? 4 times 9 is 36. All right. Am I done?
No.
Can you factor what's inside here?
Yes.
Yes.
So what would you get? Wait, you got to keep the 4.
Oh God.
So you're going to have to say 4 parenthesis, 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 parenthesis. All right, in unison, what am I going to put in the parentheses?
X plus
X plus
3.
3,
Oh, 3.
x minus 3.
What's up, party?
Does that make sense?
What if the number is not a perfect square?
If the number is not a perfect
Yeah,
square?
like if you said like plus 30.
All right, so that's a really good question. I didn't put that on here. But let's say you had, that's a great question. Let's say you had this, x squared minus 5.
Can't factor that.
Would it be like
Technically,
2.5?
technically, x squared is a perfect square. 5 is not a perfect square, but
It has a square root.
it has a square root,
2.5?
right?
So yeah, isn't it like?
So
it's like
really, I could actually do this. X plus what?
X
The square root of 5.
Yes.
5.
And then x minus the square root of 5. You see what I did there?
Yeah.
I see.
I
What you
can do that. That's legal. In fact, you will eventually do this.
That's legal.
Yeah. A lot of times your answers, remember the quadratic formula?
Yeah.
Remember, a lot of times your answers start to look like this,
Yeah.
right? You've got an answer with a square root of 5 in it,
Quadratics.
right? We'll be getting there soon.
Or my answer.
Okay? I don't think I put those on the homework, but I might have. I don't know. What if it has a middle? Okay. The ones that I'm doing right now do not have a middle because I'm wanting you to really remember and notice difference of two squares. When you see difference of two squares, would you agree with me they're really easy to factor?
Yeah.
They're a present. They're a gift from your teacher or from the SAT, test people, right? They're so easy to do. You have to, whenever you see two terms with a minus sign in between them, and one of the terms has a square, like x squared, you ask yourself, is this the difference of two squares? Right? Always two terms with an x squared or a y squared or a z squared or whatever.
Z squared.
You want to ask yourself, is this the difference of two squares? Okay, so the homework is relatively easy based on this lecture. Okay, so I'm going to pass this out, turn this thing off.